In the previous section, we looked at administering vSphere 6.x security. In this section, we will look at administering and managing vSphere 6.x resources. Specifically, we'll cover the vFlash pool and the two types of caches, the host swap cache and the read cache for VMDKs that can be implemented in the vFlash pool. We will look at resource pool management. We will look at the default share values for resource pools and for virtual machines. We will also then look at managing resource pools and the process for backing up and restoring resource pools. Distributed power management is a very powerful capability that is used in conjunction with DRS. We will look at the advanced settings for distributed power management as well as to the process of implementing and configuring distributed power management. In this video, we will cover vSphere 6.x vFlash pool management. We will cover the vFlash host swap cache and the vFlash read cache in our lab. So I'm logged in into the vSphere web client and I'm in the vCenter 223. There's a data center packed publishing site 3 here. When I expand that, I see there's a packed pub cluster with one host in there, 192.168.0.211. Let's take a look at this host. So this is a ESXi host, and when I look at its configuration, it's running ESXi version 6.0. Now, we go into Manage and we click on Settings and then Virtual Flash Resource Management. We see right now that there are no flash devices that have been enabled to this host to set up a virtual flash resource. So we need to create this virtual flash resource first. Let's see what happens when we click Add Capacity. When we click on Add Capacity, it shows us that there is one or more eligible flash device that can be used for vFlash read cache on this host. And if I select this and move forward, then the selected flash device will be formatted so that the virtual flash resource can use it and all data on this device will be erased. So I select that and I click on OK. And it's going through a process of enabling the device drivers and so on. And this takes about 30 to 40 seconds, and I'll come back to this when it's done. This took about a minute or so, and it came back. And what it shows us right now is that we have flash devices that have been enabled to use with the virtual flash system. The total capacity is 111 gigabytes, a little bit of overhead in there. But this is free space of 110 gigabytes that is actually available. And then the capacity that's available for the virtual flash read cache is also the same. It's backed up by the device which we just formatted for the virtual flash read cache, or actually just for virtual flash right now. And this is that same SSD that we saw earlier. Now, when an ESXi host is having so much contention that memory pages have to get swapped to the .vswap files, what happens is that the hypervisor now has the ability to use the vFlash pool so that it can cache the reads of the vSwap files, which is obviously much faster than writing the vSwap files to disk and reading them from there as well. So there is an added advantage to that. And to do that and enable it on the system, we click on Virtual Flash Host Swap Cache Configuration. As you can see, the Virtual Flash Host Swap Cache right now is 0 gig. I click on the edit and I check the box to enable Virtual Flash Host Swap Cache, and then I use 20 gigabytes of our virtual flash pool for the host swap cache. I click on OK, and when I refresh, it should show me 20 gigabytes. Here we are. Virtual flash host swap cache is 20 gigabytes. Now this means that out of the 111 gigabytes that were available in that virtual flash pool, 20 gigabytes have been used by the virtual flash host swap cache. Let's go back to the vFlash resource management and see if 20 gig have been provisioned, and the answer is yes. Out of the total capacity of 111, 20.95 gig, including the overhead, have actually been provisioned, and this is going to be used for the host swap files, the .vswap files. But there's still 90 gigabytes available for virtual flash read cache, and what we are going to do now is to go in and take a look at a virtual machine to see how one can enable that virtual machine and have its VMDKs actually front-ended by this read cache. So I have this virtual machine here. It's powered off. It's a Ubuntu 14.04 long-term support packed pub 1 machine. When I right-click on that and I go to Edit Settings and then expand the VMDK here, and I look down, apart from other aspects such as shares and IOP limits and so on, I see here that we have virtual flash read cache. And right now, this VMDK is not using that virtual flash read cache. So I could go in here and say 5 gigabytes of that is going to be used for the virtual flash read cache. Now, in order to enable virtual flash read cache on a virtual machine, a key aspect is that the compatibility has to be ESXi and later, which means the virtual machine version has to be virtual machine 10 and above, because this capability was implemented first with vSphere 5.5. So we are at ESXi 6, and this is virtual machine version 11. You also need the Enterprise Plus version of ESXi to support it, which we also have here. So we can set the virtual flash read cache to 5 gigabytes here. It says the reservation must be between 4 and 1024 meg. The number is too large. Now, let's click on this advanced option here. And here, what we have is a checkbox that's been enabled because I entered 2 earlier, a reservation of 2 gig. But the most interesting thing in here is that the block size of 8 KB, I can have multiple block sizes. So if I know the IO pattern of my VMDK, then I can actually go and set the proper block size so that the read cache is used most effectively. So how does one actually do that? In prior videos, I had actually shown you some tools that can be used to do that, and a tool that can be used is the vSCSI stats tool, and that allows us to look at VMDKs and virtual machines while they're running, gather information and statistics about the IO size on a certain VMDK, and we can use that information to then populate this block size for the virtual flash read cache. So we've set the virtual flash read cache to 2 gig, and we are told that this reservation must be between 4 meg and 1 gig. So we will make it say 500 megabytes. It's 512 megabytes, and we click on OK. And now our virtual machine has been configured for that VMDK to use the virtual flash read cache. Now, when I power this on, you will see the effect on this information. So recall the free space is 90.80 gigabytes and the provision space is 20.95. I right click and I power on this virtual machine. It's powering on now. Now that it has powered on, let's just go to the console to be sure that this has booted. Yes, it has rebooted. We go back to the vSphere web client and we update the information. And you can see the information has actually changed. The provisioned space is now 21.45 gigabytes, up from the 20.90 gigabytes. So the extra 500 meg that we had specified in our configuration has actually been added to this. So this virtual machine for that VMDK is using the vFlash read cache. Now, if at this point in time we want to edit and delete, for example, or disable, or maybe change, let's try change. Reduce the virtual flash host swap cache. We make it 10 gig instead of 20 gig, and we click the enter key. And you can see that on the fly, the amount of virtual flash that was dedicated to the host swap files has been reduced from 20 gig to 10 gigabytes. If I try now to completely disable this virtual flash resource pool by clicking on remove all, I will get a confirmation message which says that do I need to remove the virtual flash resource and erase the associated drives, and I say yes. And this will give me an error message which says that the virtual flash resource is in use, and that is true. My virtual machine is using that. And what I go and do now is to see, you can reduce the settings on the fly here. I go to the hard disk again, and I basically make this 0. I click on OK. Do a refresh, and it looks like we now have 11.20 gig only provisioned. Now, if I try to remove all, again, remember the virtual machine is not using the vFlash read cache. Let's see what kind of a message we get here. We get the same message, the resource is in use. So we have to ensure that not just the VMs on this host, but we also need to make sure that the virtual flash host swap cache is disabled, and not just the VMs that are using the vFlash pool. So that's very easy. As you know, we go in here, manage settings on the host, go to virtual flash host swap cache. I get rid of this message. I click edit, and I disable the virtual flash host swap cache, and then I click OK. When I go back to the virtual flash resource management, and now when I say remove all, I should be able to delete this. When I hit the refresh and I go back to my host, you see that all the virtual flash resources that were available earlier are now not available, and we have to go back to clicking on add capacity, and then we have that SSD available back to us again. So this is a very dynamic capability. You can define and change on the fly how much host swap cache is being used. A very useful capability, especially because SSD is much less expensive now, and you don't have to change your physical storage hardware, because this is a virtual capability that can be enabled simply by installing some SSDs on your ESXi hosts. Now, in the same vein, because DRS would be enabled in your cluster, if you have DRS set up automated, then if a virtual machine is using vFlash read cache, it tends to be a little bit more sticky in terms of affinities. What that means is that the virtual machine is among the last to be picked up to balance resource usage across the cluster, because it is using the vFlash read cache. You can turn it off, of course, and then that virtual machine would be treated by DRS just like any other virtual machine, and it would vMotion virtual machines back and forth across the cluster to balance out the actual resource usage on that cluster. Having covered the vFlash pool, In the next video, we will look at vSphere 6.x resource pool management. I look forward to seeing you there.